And we're back. Up next, we have Sharmilan, co-founder and CEO of Niftron, a blockchain as a service platform and recipient of the SARC Startup Award. Congratulations on this last accomplishment. And yeah, if you're interested in the future of trustworthy AI and resilient decentralized architecture, this talk is designed for you guys. Please join me in welcoming Sharmilan. Hey, Sharmilan.
Hi, folks. Hi, how are you guys? Hope you guys having a great time, and thank you for the intro as well. And hope you can able to see the screen, and I'm audible as well. So I'll directly start into the presentation. So as Fark mentioned about the title, so it's all about what we're going to talk today is about the trust by design and AI meets blockchain for a secure intelligence. And I hope you guys listen plenty of talks in this conference as well as in the recent past in different conferences based on blockchain, and you will be mostly listening towards AI as well. As we all know, like AI is booming in the last couple of years, and we can see huge potential and a lot of projects started to grow and in different domains as well. And that's where we can see a huge potential where we can merge blockchain or we can kind of fusion blockchain with AI and build potential and more secure, more trustable blockchain-based AI applications, and moreover like AI applications running on top of blockchain layer as well. So that is what it's all about the talk today. And as you maybe have an idea about AI or not, so I'm not going to touch much into the depth about the AI technologies. I'm going kind of a high level intro into the AI, and then we'll move to more focus towards how we can integrate blockchain or blockchain layer into AI applications, and mainly why we need it and what are the benefits it's going to bring to the table, and what are the potential things that we can achieve using that as well. So yeah, so as starting with AI, so it started from very long period of time from the past itself. Like for an example, if we take it as an AI evolution, it started from 1950s towards like 1980s or mid 1970s. We call it as the first AI boom, and then from 1970s 80s towards 2000s we call it as the second boom, and then now it's mostly we are into the third boom. And what are the differentiation from each of these kind of generations? So the booms, we can call it the first generation is more towards the very basic AI applications or artificial intelligence, where a simple task is performed using a programmable contract or programmable code. Or once we given a specific command and it automated and it performs every time without seeking for a human intervention or human inputs. And when it comes to the second AI boom or the second generation of AI applications, we can see a huge jump where we see a lot of potential models or else algorithms started to evolve. And then that's where we have used a lot of applications and a lot of tools and technologies developed around those AI technologies, which starting from medical domains on predictions, analysis, and also big data applications. And if we look into different domains and industries, we can see or we can witness a lot of potential applications used AI in vast variety. And it has certain limitations at that stage, but it's boomed in a huge scale comparing to the first boom. And when it comes to third AI boom, that's where it started in 2000 and still it's going in the third AI boom or third generation of AI applications. And that's where it's mostly come into a contact with data, because from 2000 onwards, like that's where the Web 2.0 started as well, where people started to create content and create data, and all of these data started to, all the companies started to preserve their data, and then they kind of started to see a pattern, and they can use AI to identify these patterns in an efficient way, analyze those data in an efficient way, and predict certain things which humans are not able to predict, or else which takes a lot of time and effort for us to predict those things, which AI can do it in a matter of seconds. And that shift kind of, we had a huge up curve. You can see it from 2020s, and now like after 2020s till now, and that's because of the Gen AI, and now we are moving into most of the times into the AI agents as well, where if you look into the AI, it's more towards it's performing, it's getting the data, it's understanding, and it's learning, and then giving the output. But what the AI agent is doing is it's more towards getting the data, understanding, learning, and it's not just giving the output, but it can able to perform tasks as well. So that's the difference between that, and that's where we are going to see how blockchain can be integrated into these, because this technology is evolving so much, and there's certain gaps or limitations that AI is currently showcasing or currently having a roadblocks in certain applications, where we can see how we can tap into those issues and how we can able to solve that using a blockchain technology. And why this talk now? So as you know, like AI is everywhere and trust is eroding, and also public and regulatory demand for more transparency, accountability, and fairness in growing AI domain. And also blockchain offers verifiable trust, that as we all know, and blockchain is one of the most advanced technology that we have at the moment to build trust between two untrusted parties in a trustable manner. And AI plus blockchain is inevitable, and that is the fusion that we are going to see how we can able to achieve that in this generation of AI applications and in the future as well. So, I mean, at a very high level, so this is how the human brain processes information. So we can see data, we can understand images, we can understand audio, video clips, and we have different sensors to capture this information. As we can capture it from our eyes, we can capture it from our ears, nose, all of these sensors capturing the data, and we process it in the brain, and then we'll become to a conclusion or making decisions or making analytics out of that. And we are doing that all of those things based on how our neurons or the nerve system is tuned and connected together. So this is the exact way that how in a high level way how the AI works as well, or in the algorithms work, where we can build models which can understand data in different types of data, and then it can able to kind of learn from that, and then it can able to predict certain outcomes or predict certain results, or do some tasks as AI agents. And it's all connected in a mapping way, which similar to how our brain neurons mapped, as well as how different models come together and they can able to perform a certain task in an interconnected way. And this is the very high level breakdown into artificial intelligence, machine learning, and deep learning. So it comes into each of these subcategories. And if you see artificial intelligence, it's a program that can sense, reason, and act and adapt a specific information or a specific data, and then it can give outputs and results based on that. And machine learning is more towards an algorithm's performance improve as they were exposed to more data over time, and deep learning where it's performed for big data sets or else large data sets, so larger data warehouses where you can able to process and you can get outcomes. And if we look into it as artificial intelligence, so we can break it down into different levels of applications, and all of these things falls into this. And the reason I'm showing this is not to go in depth and explaining of each of these categories, but in later of this talk, what we are going to see is how we can apply blockchain into artificial intelligence. It's not just machine learning, or it's not just natural language processing, but we can able to apply blockchain into all of these separate subcategories and all of these separate applications or analytics or else prediction models that we have at the moment. We can able to apply blockchain into all of these scenarios as well. That's the most important part. It's not just restricted to a data-based models or data-based AI algorithms, but it can work on different data types and different data models, and even into for range, if we can say simple as predicting a disease towards running as a AI agent, more advanced AI agent to perform a daily task as well. So all of these things is highly depend on data. So if you look at ChatGPT, or else if you look at AI agents, or else if you look into any prediction models or any AI models that we have at the moment, it's all highly dependent on the data, and it needs a large set of data to perform well and predict accurately as well. And all of these systems are highly dependent on accurate data. That's the most important thing. It's not about just the large data set that we provide, but the data set should be an accurate and real world data which kind of map with the real world scenarios, and it's not something comes as a more simulated and unrealistic data set as well. And currently, the way that people are capturing the data for these systems is one is human entry or a manual entry method, and I'm only putting the digital ways, so not only the physical documentation or OCR things, but into the more human entry ways, and also the sensor-based information that we are capturing from IoT devices, from CCTV cameras towards IoT sensors and even agriculture sensors or weather sensors, different information that we can capture from vast variety of IoT sensors available at the moment, and also through the APIs which process information and gather it from existing databases or datasets as well. But where is the actual gap here? So the main gap is, so what we have seen so far is what is AI and how the data capturing process happens and how that whole model is working. But we have to understand where is the gap, or why we need to integrate blockchain into this, and what is the reason or what is the purpose for that. So the gap here is there are multiple gaps there in AI, but I'm only putting into the gaps that we can fulfill or else we can solve using blockchain technology. So the first one is black box decision making. So AI models often operate with no visibility into how or why decisions are made. So we have certain models at the moment which can give us the reasons behind that, but then we have no visibility how that decision is made or how that decision is processed. And we have no idea, or we have no transparency over whether that information that we are seeing is actually come from the model or is it generated from somewhere else. And we have seen multiple, can call it as scams or fraud in AI-based companies where they used humans to perform certain tasks, which call it as AI. And similar like that, a certain program which kind of written by a specific logic or a code to perform in a certain strict manner, which makes the decisions in a different way, but always it gives the reasons or analytics. So the way that it shows that how it made the decisions in a strict guided rules, which won't be the same as how that decision is made by that particular model. And the second one is unclear data linkage and consent. So we don't have an idea where the data is come from for a specific model, and it can be a larger data models or a smaller data models as well. We don't have any idea where the data is come from. It's always in a verbal way, or the documentation or the contracts we have seen the data is collected from these particular people, or else the data is come from these particular organization, but we don't have any visibility or any provenance to the data as well. And or whether it's ethically sourced or not, we don't have any idea on that. And we don't know whether there's any concern asked from certain parties or certain individuals before they collect these data as well. And tampering risk onto the model parameters and outputs can be altered without detection. And also no auditability, there's no standard mechanisms to trace and verify how AI reached a conclusion. And this also links to the kind of a black box decision as well. So these are the main gaps we can see and we can fulfill using blockchain as well. So that's why I have mentioned all these gaps here specifically. And all these gaps are leading towards one thing, is trust. So if you can see, we have a provenance issue, we have a transparency issue, we have an auditable issue. So all these things are kind of the root cause of this is trust. So trust is one of the most important thing and most expensive thing in the world. And usually it can take years to earn trust with application, individuals, or people, and or products. And it's just a matter of seconds to lose it as well. So that's why trust is the most important and expensive thing. And that's why blockchain is one of the most advanced technology, I would say, to build the trust, and also most popular technology in industries where the trust is more it's the trust is more matter, or if the trust is the most valuable thing in certain businesses or certain domains or certain industries, that's where blockchain perform really well as well. Specifically, if we look into the financial thing or the fintech applications, whether it's crypto or non-crypto, blockchain is performed well because there's a high trust demand there when we send it across assets. So whether it can be a digital assets or physical assets transfers between people, and it performs really well in healthcare domain or supply chain domain where the logistics transfer between untrusted parties or in cross-border transactions, and also it performed really well in government scenarios, yeah, specifically on the voting or else the land record maintenance or digital records from physical records to digital records, because all of these applications are highly depend on trust, and they don't have trust without blockchain in the past. They don't have trust, and they always fill that trust gap by using middleman or third-party applications or third-party organizations to manually fill that gap. That's why we use blockchain to build that trust gap or build that bridge between two untrusted parties using blockchain. And that's the exact same thing that we can do to solve these issues that we have mentioned or we have identified. Some of these issues we have identified in AI applications using blockchain as well to build that trust gap. So that's why we can use blockchain here. And blockchain is the ultimate trust engine here. And I mean, it's not only about the AI applications, but if you look into any of the real world blockchain applications that have been out there, blockchain always acts as a trust engine. And apart from that, it do a lot of other things. But if you go into a very root or the deep understanding of what is the actual benefit of blockchain, you can always dive into a one point that is the trust. And it's a decentralized and immutable ledger, no single point of failure. And smart contracts is a code-driven and automated trust building. We can use tokenization to do incentivize and kind of create an economical value for blockchain-based or the AI-based applications using blockchain. And also oracles and decentralized IDs can bring bridging blockchain to the real world as well. So what blockchain can actually do, or what are the benefits blockchain can bring into the table is, one is transparency. So we can see if we actually build the AI application and we have a blockchain layer integrated to that, we can have an opportunity to see the clear data origins or the provenance of the data, and we can have a kind of an audit trail to see and track and trace where the data is actually come from. And if you ask like it's a privacy concern or a privacy issue, but we can use zero knowledge proof and different things to kind of mask that data, and we can only show where the origin of the data in a trustable way, comparing to how we have seen it now, or else we have a zero visibility at the moment in most of the AI applications. And even if we are seeing it, we can't kind of trust those claims that the companies are making it as well. And auditability is the second thing where we can face AI interference end to end, and also accountability on defining the responsibility and when and why. So we have the complete accountability over that, and also we have the security. We can kind of safeguard the models, and also we can safeguard the trained models using a public-private keys, and we can even have a version of a trained model, and we can use different models that are out there running, and we can every time we can, if we want, we can compare and see whether the current model is tampered or not. We can improve that integrity and trust by keeping a model kind of a version of the time, I mean a hash value or a fingerprint of that model into the blockchain, and we can able to kind of verify the trustworthiness of that and its integrity, tamper-proof blocks, and we have the complete audit trail of that. And we can have a real-time monitoring oversight of catch anomalies early as well. So these are the main benefits that blockchain is bringing. And if you look into high level, it's providing a more visibility towards AI applications, how it performs, as well as how it's sourcing the data to train that model, and also how it's giving us the outputs. So it gives you a kind of a bird view or eagle eye view where we can see complete transparency of how that model works, where the data is coming from, and how the outputs are coming. And also we can able to see and we can able to trust, and we can able to track those information verified by ourselves as well. And it's not going to break the business logics or else business secrets, as we can see. I mean, most of the blockchain applications has this visibility and has this provenance or transparency already in current world applications, and we can see that it's not going to break the business secrets or else how that particular scenario is performing, or the understanding of how their logics works or how the models work. It's always we can use GKB or different mechanisms to kind of keep those information private and secure, but providing the limited information that is needed, or even using the kind of a GKB to provide the necessary proofs where we can able to trust those information in certain scenarios, which is most important and most valuable as well. So just by design, like fusioning AI with blockchain, so we can have a legitimate data collection, and we can have a way that we can collect the data from different sources. That's one thing, and we can provide the provenance. But the second thing is we can kind of have a model where every individual can kind of collect and own their own data, and they can able to kind of monetize it. That's why I mentioned the tokenization or token economics model, where, for an example, I can say later on I'll touch into some use cases, but I'll say like, for an example, healthcare, where the patient owns the data and patient can sell the data or monetize the data for pharmaceutical companies or any AI models that using it, for an example, on a diabetic prediction mechanism, and they want a diabetic patient data. So they can openly ask for diabetic patient data to be given with a consent, and all the diabetic patients who have collected their data from hospitals, they can able to kind of monetize that data as their own data, and they can provide that consent to these laboratories or AI models to perform it as well. So these will open up venues where we can have sourcing data from multiple sources and in a legit way as well. And secure and decentralized storage. So this is one side is we can do it for data on a certain amount, not for a larger scale, but we can do it on a secure and decentralized storage for models, where we can train the models, we can keep the carbon copy of the model in the blockchain, and we can run it in different instances. And anytime we can cross-check whether this model is compromised or model is tampered with the existing model as well. And blockchain-powered audit trails, transparent model process is the other important thing. And it's not about transparent logic process or transparent code process, but it's about the transparent model process, how the model works, and how the model giving the outputs into a certain extent, which not going in depth into the code level. And zero knowledge proofs, we can enable lot of important information hidden, and we can provide the proofs using the ZKB as well. And the future of trusted intelligence, so auditable, trustable systems, decentralized, autonomous intelligence, human in the loop with verifiable AI. So we can combine human oversight with the provable, trustworthy AI decisions, and DAOs for AI governance and ethical, transparent decisions as well. So this is the way we can kind of reinvent the way you build trust on AI applications and models, and how this will, so currently how it looks and how we can transform this into a better trustable model. This is how the model is working at the moment. We have AI models, and we have data providers from different sectors or different individuals or different organizations. So I call it as data providers, whether it's IoT or human or a data API. And we always have a middleman who bring that trust. So we collect it from different sources, we process it in different sectors, and we transfer these data to AI models, or else we collect this, we run the AI model where we collect the data from different hospitals for a prediction, or different individuals, or else we run a data model for a kind of a credit management scenario in the fintech. So where we collect it from different credit score companies, or else banks, from individual information, and we process it. So we always rely on a middleman, and the trust is built based on that, which is not transparent or not visible for anyone else as well. But once we integrate the blockchain, so how it works is AI model comes closer to the data providers because of the layer of transparency, ownership, security, and immutability. So it's not comes together, but still the AI models perform separately, and data provided separately, but it can link and then it can directly transfer and directly monetize the information that they are sharing using the transparency, ownership, and security immutability provided by the blockchain as a trust bridge. And this is how the data evolution will looks like. So in the past, we had a physical information, so the physical records, physical data points. So the first evolution happened in the data side is where we digitize that information. So all the physical information we transferred as a digital information, and we store it in the centralized. So all the physical transferred to digital, but still we kept it in the central servers, or even we have it as a distributed databases, but it's located in central place or central country within a specific zone. But once we kind of integrating with the blockchain, so what happens is we are kind of tokenizing that information, or we call it as digitization from physical to digital. So we can call it as tokenization from digital to blockchain, and we can kind of share that data with different parties with our consent management as providing access. So we can share that data to different individuals or different organizations or even different AI models or AI agents. Whenever there's in future, whenever there's an AI agent looking for data from different parties or different individuals on a specific need or specific domain or specific type of a data, then we can able to kind of provide that access and we can able to share it using the secured portal or secured way that's provided by the blockchain. And that is where we kind of going into the decentralized AI or the future of AI, where we can kind of collect it in different ways and we can able to process the larger set of data that come from different sources in a trustable way as well. And these are some of the use cases. I'm not going to touch much depth into the use cases because there's plenty of opportunities and plenty of avenues we can kind of open up and we can use blockchain into AI. So I'll go into certain areas where we can see how blockchain can kind of integrate with AI as well. So one is healthcare, as I mentioned. Its most important thing is the health records, the AMR records. So currently, most of the countries, even including Sri Lanka as well as including most of the Asian and European countries as well, most of the times the patient records are stored in the hospitals, even with the GDPR regulations or whatever the rules that they are providing it. Most of the times it's stored in the hospital, and very few countries or very few applications or hospitals are running a process where patient records are stored with patient and providing the access. So what we can do using blockchain is we can kind of create a way where we can kind of store the patient records within patient control, and then patients can have a way to provide access to a certain hospital or a certain doctor if they need it. And this will enable, or this will be give the complete control of that data, because if my health records data are my property and I'm the owner of that data, so that gives complete control to me, and I can have a complete access to my data and ownership of my data, and I can decide to whom I can share that data and to whom I can revoke the access as well. So once you have this kind of a model, or once you have this kind of a system, then whenever there's a pharmaceutical company needs the data for models or analytics, or even AI models or AI agents, so anyone who wants the data to process it, they can kind of make a request in a portal or in a dashboard, and then we can able to kind of see if our data are matching, and we can able to kind of provide access to them, even using a ZKB or non-ZKB way, depends on the data sensitivity. We can allow that parties to access our data, and then they can use it in a legit way. That automatically monetize our data as well. We can kind of monetize that data using tokenomics model or even non-tokenomics model, whatever the ways, we can kind of monetize that data, and we can kind of create that secure portal or the bridge between the data providers and the people who are accessing the data as well. And the second one is where we can see it into the pharmaceutical drug supply chains, where the data is used in on the clinical trials and different supply chain logistic data sets as well. So we can kind of be able to process those informations, and then we can kind of securely store those informations as well. So for an example, on the clinical trials, where we can have those data done in the past clinical trials, we can kind of securely store it in blockchain, and then we can kind of process it on the AI models if it is necessary on that, as most of the pharmaceutical companies using AI models to make the drug matchings or else drug formulas as well. So they can able to get these past clinical trial data, and then they can kind of able to push that information in a secured way, and with the access concern from the owners as well. That is kind of there's zero visibility at the moment from the patients towards the pharmaceutical companies who are doing the drug. And the other one is onto the KYC and DID, which is where most of the individual data are used in shared KYC and shared DID as well. So which is kind of popular in the blockchain domain, and most of the countries are using it onto the private blockchain. That's a different topic on private public blockchain. But touching onto that, onto the private blockchain, where they use these KYC data to share with the different organizations to access it and monetize it. But the most important thing is most of these applications using shared KYC, but not getting the consent from the users as well. So we can kind of enable that process as well using blockchain. And once we have that kind of a secured way, all of these KYC and DID information can be used into different models to predict different, from, for example, from the credit score towards a larger scale onto the on issuing loans or is providing credit assurance. We can able to build it, and also we can able to predict different anomalies and different fraud schemes and different things using these particular data, as long as we have that kind of a proper bridging layer. And similar to the fintech as well, we can see it onto the credit score and different banking applications. And supply chain and logistics also, we have a lot of data processing there, and also a lot of models and AIs we're using in this particular domains as well. And we have seen in the past, blockchain is also used in these domains. So we can have a kind of a fusion in between those two things, where blockchain is one side providing the secure data, and with the concern, with the transparency, auditability, and audit trail, and the provenance of the data, and then the AI models can do what they can do better in terms of the prediction and analytics. So what we are trying to do at the end is we are building a kind of a responsible AI with blockchain. So that's the overall idea about the talk of how we can build a responsible AI with blockchain and reinvent the trust. So it comes with an ethical design where we have blockchain to ensure the transparent, tamper-proof records, and also the provenance and concern management in a secure way with the incentivized mechanism, monetization mechanism. And all of these data comes in a secure way, which is not coming at the moment or current applications. So we can bring those data in a secure way and tamper-proof way with the transparency, and we can bridge that into the AI applications, which already doing their job well. So once it comes in a legit way and in a proper way to those applications, with the transparency over how those black box models perform as well, that opens a new avenue for the AI model to perform well and performs and also reach to a vast variety of audience in a correct way. And also bias mitigation, privacy protection is there, and human oversight where smart contracts can encode checkpoints for human reviews and intervention, and regulatory compliance. So once we have this kind of an AI model reaching with the blockchain, we don't need to worry about the GDPR compliances or the data guidelines, because it's automatically the individuals providing the data, and as well as if you are reaching it from the large organizations, so certain bulk data providers, we can kind of have a proper guided mechanisms or regulatory mechanisms to access this data, and we have a complete audit trail or audit logs to those things where we are accessing the data as well, and it's a continuous evaluation as well. So hope you have a understanding now about how we can kind of fusion blockchain layer into AI, and we have a certain limitations or gaps, as I mentioned, in the AI application, which we can fulfill using the blockchain technology and blockchain layer. And once we have that one, then we have a kind of a complete, transparent, and traceable AI application where we can have the one side we can have the complete provenance of the data where it comes from, and the other side we can have the complete understanding about how those models predicting the data and how the outcome comes. And also we can trust how the model works, because we can trust that it's the exact model that is trained when it's trained as well, because we can kind of cross check with the parent model that's stored in the blockchain to make sure we are accessing the right model and we are getting the legit data outputs as well. So thank you everyone for listening, and hope you had a great time and at this session as well as today's and other talks as well, and in the past 4 days. And thanks for listening. And if you want to be connected with me, you can connect through scanning this LinkedIn and through my email address. Thank you.
Yes, Sharmilan, thank you for that enlightening session you've had. We are very short on time. I think we can take a question or two. Here are the interesting ones.
Yeah, I think we have a couple of questions here. So, can you buy trust of the Binance 1 billion recovery fund post FTX? So, yeah, so how there are two different things that you can look. So one is where you look into the real world blockchain applications or AI applications, and one side is we have the applications onto the crypto side as well. So I'm saying about real world is onto the healthcare domains or else logistics and all. And when it comes to the digital side, we have NFTs and crypto applications as well. So most of the times when it comes to the Binance scenarios or the centralized exchanges scenarios, so they build trust in a very different way. So they provide you the trust by recovering or incentivizing or rewarding you once you have lost your coin. So for an example, if you are having 100 Ethereum in Binance and for an instance it's hacked and you lost that amount, but you have done the two-factor authentications and proper verifications and validations, but still you lose it, then they provide that amount back to you. That's the way that they are building the trust onto the system. So that's totally different way. But that mechanism won't work into all the real world applications. So you can't apply that into a healthcare applications or logistics applications, because if it is in the healthcare applications and my personal healthcare record is gone, then it's no point that you are incentivizing me or else you are recovering that process back. So it's totally different mechanism. But yeah, so Binance is doing that in a way to recovering it and also giving that money back to the users in case of there's any loss happens. But into the real world application, you have to build that trust from the start itself into securing those data sets. Yes, so that's what I was mentioned. Like, so if you can see a lot of real world blockchain applications, we have complete transparent onto the smart contract codes, and we have transparent onto the logic steps work as well. The same way maybe we can apply to the AI applications, but not into the 100% same extent. But what we can do is we can use ZKPs and different mechanisms to kind of hide out the secret elements of that or business logics of that, and then we can only expose we are accessing to the correct model that is trained and deployed. That's the most important part. So as a user, I don't want to know how that exact model is, whether that model is having a, for example, if it's a neural network, I don't want to know like how many layers there, how many neurons there, or how that layer model is architecture. But what I want to know is whether I'm accessing the correct model that is deployed at the start, and also that model is not tampered, and whether the input is I'm providing is actually giving the output exactly from that particular model. So for that, what we can do is we can kind of have a base model hosted into the blockchain, and then we can have a model running into different servers, and then every time or once in a while, if you want to check it, the users have the opportunity to go and check with the blockchain to see whether that's matching with the users accessing model, and then you can able to kind of build that trust and have that model running in your machine or accessing that model as well to get the output. So it's not about completely showing the logic for the code, but you can expose if you can up to an extent, but not into the secret levels, and you can keep it in a secure way, and still you can provide the zero knowledge proof based trust to trust that particular model.
All right, Sharmilan, we're up in terms of time, and thank you so much for the really important session on building trust into AI for blockchain. Very hot topic for today. It was great having you on stage, and you are welcome to participate in any other upcoming meetings and conferences we will have. Thank you so much, Sharmilan.
Sure. Thanks for the invitation, and everyone, please stay and listen to the future talk. Thank you.